Hi guys, welcome back. We're on the 9-6 solving quadratic equations using the quadratic formula. And we're on question number 3. So here we go. Question number 3 is 6a squared plus 7a minus 13 equals 0. First step, we identify our ABC. A is 6, B is positive 7, and C is that constant of negative 13. Now that we've identified our ABC, I like to write down the formula. X equals, there was a negative boy, there were pluses and minuses about going to a radical party. He didn't want to be a square or miss the 4 awesome cuties. Party gets over at 2 a.m. Let's write the same formula, but with blanks. There was a negative boy who was uncertain because there were pluses and minuses about going to a radical party. He didn't want to be a square, miss the 4 awesome cuties. Party gets over at 2 a.m. Now what do? Well, we fill in the blanks with what we know. We know that B, if we go back to the top, B is 7. So let's plug that into all the B spots, which is here and here. A is 6, goes here and here. And C is negative 13, and that just goes right there. Beautiful. So now our job is just to simplify. This first one is just going to be negative 7. There's no double negative this time. It's just a negative 7. Plus or minus, let's clean up that little part. 7 squared is 7 times 7, which is 49. Now this is the cloud of doom. Be careful. I see 2 negatives. The 4 is negative and the 13 is negative. So I know I'll have a positive here. 4 times 6 is 24. And that's going to be times 13. So let's see what that's going to be. That's going to be 312. And that's all going to be over 2 times 6, which is 12. Great. Now again, our focus is going to be on cleaning up this radical area. And hopefully we have some beautiful perfect square in there. So let's keep going. So we have x equals negative 7 plus or minus the square root of 312 plus 49 is 361. That's going to all be over 12. Square root of 361. Wow, is that even a perfect square? Let's look. Here's our perfect squares. This yellow 361. I found it. Yep, it's going to be 19 times 19. So I'm going to continue on the next board. That just jumped off my desk. We have x equals negative 7 plus or minus the square root of 361 all over 12. Let me double check with my other board. Yes, I had it memorized. Okay, so now we know that the square root of 361 is 19. So let's keep going. Plus or minus 19 all over 12. And then we split and solve. So we have negative 7 plus 19 all over 12. We have negative 7 minus 19 all over 12. I think we're going to have some interesting answers here. So 19 take away 7 is 12. 12 divided by 12 is 1. So there's one of our solutions, one of our intersection points, which is nice. And let's see what the next one's going to be. So that's 19, negative 19, go back 7 more. That's going to be negative 26 divided by 12. Well, that's not very interesting. So we need to reduce. Can you guys think of a number that goes into both? Well, the one that stands out in my brain right now is I can see that 2 goes into both. So how many 2's are in 12? 6. How many 2's are in there? 13. So negative 13.6 is your final answer. Negative 13.6. If you remember from middle school, you could take this improper number and turn it into a mixed number if you so desired. I don't care. You can leave that as your answer and I'm good to go. 1 and negative 13 over 6 is great. However, if you're the kid that wants to turn this into a mixed number, you do it like this. 6, the denominator goes into the numerator. 6 goes into 13 2 times. 2 times 6 is 12, and there's a 1 left over. 2 and 1/6. So another way of writing this exact same fraction is negative 2 and 1/6, but I would accept either one. It's completely up to you. Great job, guys. We are now done with question number 3. If you haven't yet tried, try to do a question by yourself. Not 5 and 6, not yet. Those are kind of more different. Actually, they're easier, surprisingly. There's an area that we just have to stop because we can't go on any further. But why don't you guys try number 4 on your own if you haven't done so already, and come back for the next video. Great. Thanks, guys.